Hi, I'm Justin Kirk, and this is my video series called the Card Series. And in this video, I'm going to show you how to make this Chain Lightning card. So what it is you click the button and it uses the card. If you click again, it uses Chain Lightning. So like, for example, for Fireball, it makes my staff go like fiery, and then you shoot a fireball or whatever, right? So it's pretty cool. I've also made it so when I press Z on my keyboard, it just does the effect permanently. And just for like testing purposes, just for like right now, makes more sense to have it like that. So if I go in here, like it breaks the barrels and stuff. See if I can find some enemies. Hang on. Kills enemies and stuff. Yeah. Anyway, so let me get out of here. So the first thing I'm gonna do is I'm just gonna let me hide all of this stuff, because you're probably not gonna have this in your game. This is just specific to my game. So let me hide everything, and let me hide this stuff too. Okay. So in your scene on the left, just right click somewhere and you can create a 3D object. It's going to be a quad. I'm going to make my quad 30 by 30 by 30. You can make yours whatever you want. My scale is really big on my game, so I have to use a larger number, but you'll probably get away with one if you're not, because you could just zoom in on it or whatever, right? And then you could rotate this 90 so that it's facing like directly downwards. So basically what the lightning is it's just a shader that's applied to a quad, and then the quad is stretched between 2 points, and then from that point it gets stretched to another point, etc., until like that's how the effect is made. We're just gonna go ahead and rename this to lightning prefab, and then at the bottom here I'm just gonna create a folder, and I'll call this Chain Lightning Tutorial 2. And I already made a tutorial, and this is just a remake because that one was like too long. So I just remade it, so that's why there's two folders. And we're just gonna right click in here and create a new shader graph. It could be a lit shader graph, and you can call this Chain Lightning Shader. And then below this, you can right click and create a material, and you can call this Chain Lightning Material. And then in the material at the top, like where it says shader, you could just go to the drop down and type in chain and just find the shader you just made. And then we'll just drag this material and put it onto the quad that we put into our scene. Okay, so from here, we just want to edit the shader. So just double click on it, and you can just drag this so that you can see your quad while you're editing it. Yeah, just like that is probably fine. Okay, cool. So the first thing you want to do is just make this transparent, and then change this from alpha to additive, and then change the render face to both, change depth right to, oh, you can leave depth right, turn off cast shadows and receive shadows. It doesn't need to cast or receive shadows. Don't remember if I changed anything else. Yeah, I think that's fine. So you could turn off the preview if you want, because we're gonna use the actual object for the preview. Yeah, so to do this, if you just right click anywhere in the space, click create node, and you can make a rectangle. So the width of the rectangle is going to be 0.11, and then the height of it's going to be 2. What you should do actually is you should make these editable values that are editable in the inspector. So just if you click on the Blackboard option, you can add variables to your shader graph, and just click plus, and you can make this a float. Just call it width, and then for height as well. And you could just drag them into their spots. And then if you click on them, you can change the value to 0.11 and 2. So what we want to do is, if we just right click, we can create a simple noise. And let's just change the scale to 25 for now. And we'll drag this into the UV of this. So when you do this, you see that it goes absolutely crazy, right? So we don't want it to just be the simple noise, because simple noise, if you look at it, anywhere where it's white in this picture is where it will be white here. And anywhere it's black, it will be black, but that's not how lightning is. We want it to be slightly skewed, but we want it also to retain the actual shape. So we want the UV as well. So the UV is like this is the image without distortion, okay? And what we're gonna do is we're gonna get rid of this, and we're gonna put this into a lerp node. So if we right click here, we can create a lerp node. This is gonna be value 2, and this is value 1, okay? And then we'll put the output to the UV. So, and then we also need a float value here for the noise amount. And we can just drag that in down here and put that into the T value. So the way lerp works, there's two values. So this is the default way the image looks, or the rectangle looks in this case. And this is what we're lerping to. So this is the noise value, right? So if we put this all the way to 1, you'll see that it goes back to the same exact thing that we had before. And if we put this to 0, it goes to the thing. And if we put it to halfway, you can see that it's kind of a mixture of the two. So this is the way that it normally looks, and then this is the noise, and we want to add noise, but we also want to retain the shape of the object. I hope that this isn't too confusing, but yeah, so this is kind of like the distortion amount or the noise amount that we have, right? Let's just change this to a smaller number because we don't want it to be too crazy. We just want it to be like a little bit messed up. And then we're gonna make this animated using the time node. So if we go here, we can right click and create a time node. And then we also need a speed that we're gonna multiply it by. So we'll just make this a vector 2 and we'll call it the animation speed or whatever you wanna call it, doesn't matter. So then if you take the time node, you can put it into a multiply node, and then we're gonna multiply this by the animation speed. The reason we're using a vector 2 is because we wanna be able to control the animation for left and right and up and down at the same time. So we don't wanna just use a float value because that will do both at the same time, and we wanna be able to, this actually has to go into a tiling and offset node. Oh, okay, the speed is 0, that's why it's not moving, okay, gotcha. So we'll put this to 1. So like I said, the reason we're putting this is a vector 2 is so like if we edit the X value, that's like the left and right of this. And if we edit the Y value, that's the up and down. So like we can choose if we want it to just go up and down or left and right or both if we want to, but we don't want it to just be the same because if it's the same, it will be going down and left and it kind of looks weird like that. So we don't really want that. The other thing you could do if you really wanted to is you could make a sine wave to make this go back and forth. We're not going to do that. That's probably a little bit too complicated for this video, and I already have something that I kind of like as a result anyway. So this is pretty cool for the output. So then, yeah, after this, you just need to multiply it by a color. So we'll just put this into a multiply node, put this as the B value, and then we need to add a color. And the color can be HDR. If you don't set this to HDR, you won't be able to make it glow, so it's important that it's HDR. So then you could just change this default color to like a blue and then turn up the intensity. It's fine, and then we just need to drag the color here, put it into the A slot, and then this can go into the base color, and we'll save it. So one thing I want to let you know is that if you do want to outline the lightning, so like have a line around the lightning, you could do that with if you had a second rectangle. So if you create another rectangle node and you put the width and the height into it, but the width has to be subtracted, subtract 0.1 from the width, and you put this into here, and then you could put this, instead of using just one color, you could put this into a gradient UV. So if you created a gradient, you could put this into a sample gradient node, and then the time would be this. And then you could put this into the color if you wanted to. So instead of having a line here, oh sorry, we actually have to put the output of the lerp node into this as well so that it moves. So see how there's like a black line in the middle? So then you could mess with the settings. So you could change this to be the white, and then you could have a line here that would be blue. Looks like the opposite, so this could be blue. And then this could be white. And then you can see, oh shit, okay. And then we would probably want to subtract 0.05 so that it's more like that. So you get where I'm going with this. So if you wanted to, you could have an outline for the lightning. That's how you would do it if you want to do that. I don't like the way that ends up. So because we use so much glow in the lightning effect, it's not visible. Like it's not easy to see the difference between it unless we change it to alpha instead of instead of additive. But again, we don't want that. We're just going to use a color. So, but that's how you could add an outline if you wanted to. So let's just get rid of that. So this is the full shader. So let's save this, and then we'll just dock this up here for now. And then if we go back into the scene, you can see that this is the lightning piece. Now we've got this background that's not transparent, and we don't want that. So let me just go into the graph settings and see why it's transparent. Should be fully transparent. And let me just put this into the alpha for now. Ooh, that looks cool. Okay, so putting it into the alpha looks like it got rid of like that box around it or whatever. So this is actually the easy part of this. I learned most of this shader. Like this is pretty much a copy paste shader from Gabriel Aguirre Prod. So if you look him up, he has another video. His is a little bit different though. So his is top-down lightning. Mine is cross lightning, and his doesn't really use planes or anything like that. It's just using a VFX graph, so it's completely different. But the shader, like this shader, I learned from him, so I'm just gonna give him credit there. But anyway, so now we need to actually create the chain lightning. So we have this. So what we need to do is, this is the lightning prefab. We just want to drag this into this tutorial folder. And this makes what's called a prefab. So we can reuse the prefab over and over and over again, okay? So if we go ahead, we can delete this now from the scene. So the second thing we need is a spark ball. So to do that, if we right click here, we can create a visual effect graph. If you don't have visual effects graph in the spark balls. If you don't have visual effects graph, when you go to right click, just go to window and go to package manager. And then in the package manager, change this from My Assets to Unity Registry. And then you can just type in visual, and there should be an option for visual effects graph, and you can click add. Mine says remove because I already have it installed, but yours will probably say add. There's two real parts to this. So let's just drag the spark ball into the scene. And if you double click on it, it should zoom in on it. It's really small, obviously, in the thing, because my scale for my plane is 30 and the scale for this is currently 1, so obviously it's going to be really small. Might be larger on yours if you used a normal scale for your item. But anyway, if you double click on this, it should open a graph very similar to the shader graph, and you should get a full size thing like this. So let's actually not make this full screen, because we want to be able to see this and the spark ball at the same time. So let's do it like this. Okay, so the first things first, we're just gonna change the count. So instead of having 16, we're gonna have this be, we actually don't want a constant spawn rate. So let's go ahead and delete the constant spawn rate, and we'll just add a block, and it's gonna be a burst, like a single burst. And we're gonna make this 1,000 particles. The capacity needs to be changed from 32 to, technically 1,000 would be fine, but we're just going to change it to 10,000. Okay, the lifetime random can just be between 1 and 2. And then the position, we want to put this into a sphere. So it's going to make, like, the balls that are in between the chain lightning, they're spheres. They're not just like random velocity things. So we just want to press spacebar here, and we can just type in sphere, and you can set the position to an arc sphere, and we want to do that before we set the velocity. So then we can right click over here and just type get position, and then we're going to create a vector 3, and we'll call this burst speed. Oops, burst speed. And you can multiply these together. And then the burst speed for us is probably just going to be like 15 for now, just until we see what that is. And you could just put this into the velocity random and just change this from, create another multiply node, and we'll just change this to -1. Okay, so that looks like really massive. I'm not sure if that's just because I'm zoomed in though. Let me just save this again. Okay, so we definitely don't want it going to 15. Let me just enable my plane so I can see how big that is. Hang on. So this is my plane, and when I press save, it's still relatively small. Okay, so that's okay. So we'll leave it at 15 for right now. Then we want to set the size of it. So set size. We'll just set it to like 15. Now, when you save this, this won't have an effect because by default, the visual effects graph has this set size over life node attached. So the reason that it doesn't change is because this is set to overwrite in the composition. So when you click on this, your inspector shows the values of this, and we just want to change this to multiply instead of overwrite. So that way, when we change the size, it actually affects the size. Also, we have this as a default particle. We don't want the default particle for this. We want to make our own particle. So I'm just going to right click at the bottom, and I'm going to create another shader graph. Where is it? Shader graph, European lit. And we'll call this lightning ball. Lightning ball is fine. And if you double click on this, let's just drag it out as well. We'll put it over here so it's kind of big. You can turn off all these things or whatever. Just right click and you can create a texture 2D node. And then the texture is going to be the fireball one. So this texture is available in the other video that I made on how to make a fireball. So if you want this texture, I've linked it in the other video on how to make a fireball. So you can literally just go and get it from there. So yeah, so then we just want to do a gradient as well. So sample gradient, actually just type gradient. And then this will force you to put it into a sample gradient. And then we can multiply these together. And then the output of this, so the output of the alpha can go into, oh my god. Okay, sorry, make this transparent. So the output of the alpha can go into the alpha channel. And then the output of this can go into the emission and the base color. Okay, and then the gradient, we just want to make this like blue. So let's go ahead and save this because we're not really able to see. This doesn't actually show what it's going to look like. Maybe we'll just try the main preview. Hang on. Okay, that's not what we want. Let's make this blue. And then the end, maybe it just needs to be white. Okay, so then let's save this. And then back in the VFX graph, we want to just, in the output particle quad, we just want to choose that shader graph that we just made. So it's called lightning ball. In the shader, you actually have to enable VFX graph for it to work. So in the graph inspector, if you click graph settings, you can enable support VFX graph. Turn off these shadows. We don't need that. And then change this to additive as well. We'll check if additive looks okay because it might need to be alpha. We'll find out in a second. Okay, so we want this to start at 1. Actually, sorry, we'll start at 0.5, then go up to 1. Sorry, let me just add a point here in the middle. Or is this a point? No, it's not a point. Add key. So we go like that. Oops. Just like that. Let's see if we can save this again. Okay, so additive is not working. That's too... all the particles for additive stack on top of each other and it makes it really bright, so we don't want that. So just turn it like that. We might need this to be a little bit bigger. So let's do 50. Okay, so it's not high enough off the ground. So let's move this up here so we can actually see it. And just, instead of this, let's just put the alpha into there. Ah, there we go. That's what we're looking for. Cool. Okay, so the middle of it is kind of blue and then the outside is, so we wanted the opposite. So let's go and get rid of these keys. If you just slide them together, it gets rid of them. So then you could just make this white and then blue here. No. Can this be white? And then blue on both sides maybe. And then we will have a key here and a key here for blue. And then this can be blue. And then, so it looks like this key is responsible for the middle. So we'll just turn that up. And then this key needs to be blue. Like that. And then this key can be blue too. What if we save it like that? All right, and we want this to go up to 2. So double the size. That way it's like, it grows huge and then it goes small again. Let's see. So what if we turn this to 25? We want this bigger. We want this to grow more in a short period of time. Maybe instead of waiting for that long, it just goes big really fast and then it goes small. So then let's add another key and bring this one up as well. And then it can be rotated kind of like that. Okay, and then this should take longer to get there. That might be good. Okay, this is looking pretty cool. Okay, so this is like, if you look at this graph, basically it's starting at 0.5 of the size, and then this is time, right? Like the bottom part is time, so 0 to 1 second. Actually 0 to the lifetime, not 0 to 1 second. So if it's dependent on the particle, but then it gets 3 times the size here, halfway through, and then it abruptly dies off right before it disappears or whatever. So one thing you could add is one more key, add another key here. So what if this goes a little bit to the left? That way we have some idle time at the smallest size. And then if we click this, we can do like this, and then this can be, because we don't really want it to, yeah, like that. See, that looks really cool for electricity. Okay, so let's save this. So that's a spark ball. So then we need to actually add another context. So it's just gonna be, actually we want the whole system. Let's see, system, empty particle system. Oh, interesting. Okay, so this has all the pieces, but it doesn't have anything set. So we also want this to be a burst. So if you press space in the top part, you can just, oh my god, burst. And this can just be like 100, and then the capacity can be 1,000. It's the same kind of deal with these numbers on the side here. So we just want to copy this and just paste it over here. So then this can go, oh, we don't have any of that stuff yet. So we just want to set lifetime. You can set this, if you're not seeing a random on this, hang on, let me shrink this down a lot. If you're not seeing a random on this, you could just, on the right here, under random, you can just per component. And then just set this between 1 and 2. That's fine. So this is going to be a burst of sparks that goes flying, okay? So let's just add per set velocity. We want to change this to have random as well. And it's the same kind of deal where we can put this into here, but we want this to be a lot faster. So let's multiply these numbers again. So we can just multiply, and the number we multiply by could be like 3 maybe. So multiply by 3. Oops. On all of them if you can, and then this can get multiplied too. We can't use the same multiply node though, because yeah, so we just need to multiply by 3 just like that. Okay, so then the output of this can be just a default particle. So if you go in here, not a shader, sorry, the main texture, changes to additive. And then just look up default particle. I spelled it wrong, just type particle. Okay. And then on this, set the size. You can set it to 25 for now. We'll just save. Oh, we need to set it to an arc sphere first. So just type in sphere here and set position arc sphere. Okay, so now we have some particles coming out. So let's change the lifetime to 4 so they last a little bit longer. And then instead of additive, let's change it back to alpha. And then instead of default particle, let's change this to the other particle system. So default particle system, this white one. Okay, and then we just want to set color, and we'll just make these like blue with some intensity. Okay, so this needs to be 1 instead of 25. The speed can be 5 times faster instead. Okay, and the next thing we want to do is we actually want to stretch the particles so like they're not the same size every single time. Like they shouldn't just be round. Spark should be flatter. So let's change the orientation. So if you click the bottom one, you can press space. Oops. Orient along velocity. Okay, and then we want to change the scale. Oops, that's not what I wanted. Scale. Scale. So just put this right here, and then we can make this random. So for this, we could do between 3 and 5 for the Y, and this will stretch it into like a spark. And then we just need to make it smaller, so we'll put it back to 1. Okay, and then the color is kind of bad, so let's just see, is there a gradient option? Okay, so we'll change this to like blue, and this can be white, and both of them can have intensity. Okay, and they could just be, this could be just slightly bigger, so maybe size 2. Okay, and the brightness can be significantly more. The lifetime could be 2, and then the speed can be 8. Let's make the speed even faster. Let's make it 16. We really want these to just go completely flying. Even faster, maybe 32. Okay, and then we need to do velocity over life. Let's do that. And then we'll just change it from where it is now to multiply. And then we should be able to just, we want it to start out at 1, which is as fast as it's going, like the normal speed. And then it immediately comes down. Or like that. Yeah. Copy value, paste value. There we go. Okay, let's try this again. Okay, that looks really cool. I really like that. Okay, let me just see. That might be too big, and I also think I might have a orthographic view on. Or no, I don't. Oh, it just feels weird. Okay, so now that we have the prefab set up, so we have the spark ball, which is going to happen in between them. This needs to be way smaller. That's way too big. Let me just see. Let's go back to the spark ball for a second. And we're just gonna put this down to like 12, like half the size. Still, that's kind of massive. Let's try 5, maybe. Nah, that's probably good enough. That probably might still be too big, but anyway. So let me just put this back. So now that we have the 2 prefab set up, so this is what's going to happen. So this is going to make a line between the 2 things, and then this is going to make the explosion. So let's go ahead and delete those. We're going to need to add a script. So because you're not using my game, I'm just going to create a 3D object. It's just going to be a sphere. This is going to be your character, so you can use this as well. So we'll just put him in the middle of the room. Actually, let me just set him to 0, 0, 0. Cool. So that's where our lightning is going to come from. So this could be the character in your game, for example, because you're not using my game. You're going to have your own character and your own scripts for that. So we're going to pretend that this is your character for right now, okay? So if you right click at the bottom, let's just create a script, a C# script, and we'll call this the Chain Lightning script. Okay, and you can go ahead and just drag the script onto your character, or your sphere in this case, or whatever you put the script on. It doesn't matter, as long as you attach this script to an object, it will work. So then you can double click the script to open it. So just change update to fixed update. Alright, so if input get key key code. Let's just make this Z. That's what I made it for the other thing. Actually, I already used that. Let me just put this as L. It can be L. So when we press L, this is going to happen, okay? So, hang on. Okay, so let's make a variable at the top. We're just going to make this public. You can make this... Yeah, just make this public. It'll be the game object spark ball. And then public game object lightning. After you've made the 2 game objects in your script, you can go into your sphere and you can drag the 2 prefabs that you made. So put the lightning prefab in there and the spark ball into the spark ball spot, and then you can save it. And then, so when we press L, what we want to happen is we want to draw the quad, the lightning, in between the player and the destination. So let's set that up. Okay, so the first thing we need is the start location. So the start location is going to be the object that we're attached to. So vector3 start location is equal to the transform.position. So we're starting, we actually want to put this in front of the sphere because you want it to like be a little bit in front of it. You don't want it to be coming in like from the middle of the sphere. You want it to be coming from in front of it. So if you just put forward, so this will get the front of the sphere instead of having it. So like, because we don't want the lightning to come out of the middle of the sphere. We want it to actually come out of the front of the sphere. Obviously your sphere is not going to be, you don't know what direction it's really facing right now, but okay. So then the rotation of the plane is going to be, we just need to make a quaternion. And it's going to be new quaternion.Euler. Actually, just to do quaternion.Euler. And then we'll do 90, 0, and 0 for this. And we're going to do transform.rotation times this. So the reason we're multiplying this by 90 is because our plane that we added to the game, let's put it back in for a second. This is rotated by 90 degrees, okay? So if it's not rotated by 90 degrees, it will be vertical, like it'll be like, you'll see the flat side of the quad and it won't be as, like it won't be visible. So it needs to be, we rotated 90 here, so it needs to be rotated in our code as well. So let's go ahead and delete that again. So then we need to instantiate this object, but we also need the destination of where we're going to be putting the object to. Okay, so here I've copied some code from my actual player script. This is just a plane. This isn't like a game object plane. This is like a imaginary plane. Like it's just using the plane class. It's not the game object version of a plane. This is just like an infinitely wide plane so that we have something where our mouse can detect where you clicked on or whatever. And then this is the script that I use to get a target point via clicking. So if you click somewhere on the screen, this will get the vector of where we're going to. Now we need to get this before, actually we don't need to get this before we instantiate the object. We should instantiate the object and then resize it. So what we'll do is we need to actually create a game object and we'll call this the attack, or call it whatever you want to, it doesn't matter. And then we need to instantiate the game object. Okay, so here we have the code to instantiate the game object. Make sure you're using the location where your actual prefab is, okay? So in my case, if I go to my Chain Lightning tutorial folder, I have this lightning prefab, and if you click on it at the bottom, it should tell you the exact location. If you don't see it like this, if you're looking at it and it looks like this, you can drag this little bar thing at the bottom to the left and it will actually change it to this view. And when you click on it at the bottom, you'll get this path in the folder where it actually is. So that's what you actually need to put here. So let me just change this to actually match mine. Hang on. So mine's Chain Lightning tutorial 2 / lightning prefab. Okay, so this will make it will spawn this lightning prefab at the start location. So the start location is our sphere right now, and then it will use the rotation of the sphere, but it will also it will add this 90 degrees because it's supposed to be flat, it's not supposed to be angled. And then this gets the target point. So what we need to do now is actually scale it so that it makes sense. So hang on, let's save this. So then what we need to do is get the distance. So vector3 has a function called distance, and this will get the distance between 2 points because so this is gonna make it look in the direction, like the rotation, it's gonna look in the direction of it. We want it to be the size of between the 2 points. That is like, so the point you clicked on and the point of the player. So we want to do target point and start location. Okay, and then we're gonna move the attack position to be halfway between the target point and the current point. So the reason we're doing this is because when you resize something, the origin of this, like this quad, is in the middle of it. So if we make it larger, if we don't move it to halfway between the 2 points, it will just be it will be on the wrong side of one of the things. So it needs to be halfway in between the two things when you scale it. So let me just visualize that for you. Hang on. So if we put this down, hang on, let me just do that. So we have this, right? If we scale it, look what happens. It grows both directions, right? So let's say this object is right in front of this sphere here. Okay, so you have this object in front of this sphere, right? And it's coming out of the front of it. If you resize it, look what happens. It goes through the back of the object because it's resizing from the middle. It doesn't resize like only in one direction. Although that would be cool if it did, but when you resize it, it will go, it resizes on both sides. So we need to move it half of the amount that it's been resized forward so that it will be, so that's what this is doing. So we're setting the position to be halfway between how long we're gonna move it or whatever. So let's do that. And then we need to set the scale of the object. So we need to save this into a variable like this. So the only transform that's changing is the y-axis. So if you go back into the scene here, so like when we want to make this longer, we don't have to change the z or the x. The only thing we have to change is the y-axis, and that's why we're getting the distance of how far between the 2 points is. So we don't need to change z or x. So what we have in our code here is we're setting the local scale to be a new vector 3. We're keeping the scale of the x and the z, and then the y-axis is going to be the distance, which is the distance between the 2 points. So hopefully I haven't lost you yet. So this is probably good for right now. Let's go ahead and see if we can actually test this. Hang on. Okay, so it looks like we haven't set the rotation, so we need to rotate the object towards what we're looking. Okay, so we need to set the rotation. In my game, my character rotates around naturally, so when I'm moving around, my character's forward changes, so that's why this works for my normal. In my normal code, I didn't have to do this, but what we need to do is create an angle, which is the angle of the target point minus the start location, right? And then we rotate the object on the angle of the next hit. So, and then we also have to multiply by 90 because again, it has to be flipped. So when we do this, hang on, I'll show you. So when I click L now, you can see that it goes directly to where I'm clicking. This is exactly what we're looking for. Now this is way, way too bright. So we need to turn it down like a lot. Let me just go back to the chain lightning material, and we're just gonna, I don't know, maybe 3.2 is better. Okay, so after we've done that, we need to spawn that ball that we made at the point as well. And we also need to destroy the object that we've created. So this object that we're instantiating, we need to destroy it. So we could do game object dot destroy attack, and then we just need to have it wait like a second. So when you use destroy, this is the thing we're destroying, and this is how long it will be destroyed. Just give it like a second, that way it will like stay around for like a second and then disappear. And then we're gonna instantiate that ball of lightning. So we have this spark ball that we made, right? So in this, it's the same exact code as the other instantiation thing, but we'll just type spark ball instead. It should create it at the thing. And again, we want to destroy this. So what we can do is in this instantiate method, we can just call destroy directly on the method without putting it into a variable. And then again, at the end, we could just put it to like 2. So this should actually be longer than the life of it. So maybe 3, because the VFX is up to 2 seconds. So we'll give it a little bit longer than the life of the VFX. So it will disappear naturally after 2 seconds because it's only a single burst. It's not going to have a repeat option added to it. So you don't technically have to destroy this, but even though it's not playing anymore, it will still idle in your scene, and it will like if you have too many of them that get accumulated, it will cause lag. So let's go ahead and run this again. So it looks like we put the wrong position on this. So we're starting it at the start position, but we want is the target point instead. And it also looks like that explosion is way too big. Like the sparks are going too crazy, so we probably need to do something about that, but oh my god, okay. So go back into your spark ball, and we just need to turn this down. We're just gonna put this to 1. That's like, it's way too much. And then just change the count to maybe like 15. We just want this to be very, very, like this isn't the main part of this animation or this visual effect that this is. So we just want just a smaller, like it shouldn't be taking up the whole screen. So hang on, let me just try this again. Okay, so the color is still too bright for the lighting material, so just turn this down a little bit more, maybe to like 2 for now. And then the spark ball, maybe slightly longer, so instead of 0.5 to 1, maybe we'll do 0.8 to 1.5. Oh, those are the remaining particles of the thing. They're getting too small, I think. I thought those were part of the spark effect, that's why I was so confused. Okay, so in the spark ball VFX at the bottom, just don't have this go so low. Make the ending at like here instead. So instead of it going all the way down to like 0.5 or whatever, have it just go down to here. That will look better because those sparks are too small and that's why it looks weird. Still, no, that's still too, hang on. Let's just go to here. All right, that's perfect. So, like I said, you can just mess with this yourself. I could be playing with this all day if I keep going on, and the video will end up being like hours, right? So this looks pretty good for what it is. So now we want this to be a chain lightning. So after it hits here, it should find a random point in the room to be the next point and just chain like 5 times or something, okay? So let's get out of this, and what we'll do is we'll wrap all of this into curly braces. And then we'll create another for loop after this. So int I equals 0, I is less than 5. Like this. And then we basically need to do the same thing, okay? So the start location is going to be where this one ended. So we need a vector outside of this called previous location. So when this is when we're done calculating the target point or whatever, we want to set the previous location equal to the target point. So the previous location is going to be the start position of each of these. Like each one of them is going to sequentially change. So we'll want to make the, we'll just call this attack 2, it's fine. So, and it's going to start at the previous location. And then it needs to do the same stuff that this one does. So the target point and all this stuff is the same. Actually, we don't need the ray cast. The target point is going to be a random point. So we'll do random.range, and my scale is relatively big. So make sure you check in your actual game where the minimum and maximum that you want this to be able to chain to is. So I'm going to be putting this really big, but you don't have to do this. So it's going to be a new vector 3 and random.range -200 to 200. And then 20, and then another random range like this. Remember, you don't want to random the y-axis. You want all of them to just be at 20. You want them above the ground, okay? 20 might be way too high, so just make sure you're working within the scale of your own game, not my game. So 20 works for me, but yours could probably be like 2 off the ground or something like that might work for you. So the distance is still going to be, it's going to be between the target point and the previous location. And then the angle of the hit is going to be that. The position is going to be... So all of these have to be attack 2 instead of attack. Okay. Just get rid of this extra line. Okay, and then we need to instantiate the this thing. Again, it's going to be at the target location. Let's find target point. And then after we've instantiated that, we'll set the previous point. Oops. Previous. Can I type today? Previous point location is equal to the target point. Okay, and we also need to destroy the attack 2. So we're not destroying attack 2, and that's why it just sits there forever. So we need to destroy attack 2. So we'll just copy this one, and right before we set the previous location, we'll destroy attack 2 after 1 second. So also the other thing you could do is you could put this into an enumerator. Do lightning, and then what we want to do is just copy all of this code from this and paste it all into this do lightning command, and then just take this yield new return and put this at the bottom here. So the reason we're doing this is because every iteration we want there to be a delay before it actually shoots the next lightning, and we can actually put this at the top too. So like in between these two, before we start this, there could be one as well. And then, so when we press L, we should start this coroutine, do lightning. Okay, and then the last thing that we want to do is we just want to make sure that this doesn't get pressed twice in a row. You should use a state machine for this, but like this video is already going to be way too long. So we're just going to create a Boolean value called already lightninging. Okay, and it's false. And then we'll just put an and here and not already lightninging. So then we'll set this to true. And then we could just create a void wait for lightning and have it change this back. And then we can just invoke this method, wait for lightning, after 2 seconds. So this means that you won't be able to, you'll only be able to use this attack or whatever once every 2 seconds. So if you don't add this, that's why it's shooting everywhere all at once, because when you're clicking, it's doing it a bunch of times, because fixed update runs every like frame, right? So every frame, up this, I think 50 frames per second, fixed update runs. So you don't want this happening 50 times instantly when you click once. You just want this happening once, and then after 2 seconds, you can use it again. So I'll show you. Okay, so this is looking really good. Some things that I probably would want to change are the lightning prefab is not bright enough anymore. So if we go into the lightning material, you can actually change this while you're playing. Materials will actually save as you're playing. So this is not bright enough. It needs to be like, maybe make it 3 and see how that looks. Whoops, I put L. Okay, and 3 is still not big enough. Also, the width could maybe be bigger, and then the noise amount could be 0.55. Okay, well, width has to be smaller then. Maybe just make the animation speed like 25 by 25 so it goes crazy. I think we don't have the distortion amount, do we? What's the noise amount? Simple noise, it's just 25. Let's make this 55 and let's make this 25. And then let's save this and go back to the game. We should have put a thing to this. See, that looks way better. Okay, so in your shader, obviously add an option to control the noise scale. Like, so this simple noise, that we didn't add anything to control the scale of the simple noise, so that's why, anyway, yeah, you could spend hours messing with these settings and just doing however you like. I hope you guys found this tutorial informative. If you did, make sure you like and subscribe. And yeah, this took a little bit longer than expected, but sometimes I just start having fun when I'm messing around with this. For my game, it looks like the scale might be too large. So if you find your lightning is going outside the boundaries of your game, just change, because I'm using a random range of 200 to 200. You can, again, make the numbers within your game. So like for me to fix it now, I would probably do 100 by 100. And then I could save it, and then I have to relaunch the game, obviously. Yeah, so I mean, that's it for the Chain Lightning tutorial. you can use this for quite a lot of things. So not just for like lightning or attacks or anything like that. You could use this for scripting, like for enemies, for example. Like I have like enemies that are, I mean, I'm using a nav mesh obviously for certain reasons, but you could use this for stuff like that as well if you're trying to like pathfind, and you could use this for so many different things. It's not just for chain lightning. There's lots of different things that you could use this for. But like I said, I hope you guys found this tutorial informative, and if you did, make sure you like and subscribe, and I'll see you in the next one.